Section 1.3, Trigonometric Functions. There are a few things I really want to hit on that are very important here. One is how we measure angles is very different. Okay? Radians are directly related to our unit circle, okay, with a circle with a radius of 1. Given an angle, let S be the length. Let's do this. Let S be the length of the corresponding arc on the unit circle. Okay, so if we have that, the length of the arc, okay, based on our angle. So we say the angle corresponding to an arc length of 1 has a radian measure of 1. Now, because the circumference of a circle is 2 pi, and 360 degrees is equivalent to that, we can often use the conversion factor 2 pi is 360 degrees, or the equivalent pi is equal to 180 degrees. Now, here's a table with some common degree and radian values that go together. I'm not going to dwell on this. Look over this and be familiar with how these are located, because it'll make a difference as we go through the rest of this section. So example 1, express 225 degrees using radians. All right, 225 degrees in radians. Well, we want to use the conversion factor. 180 degrees is equal to pi. So reducing that, we get 5/4. So 5 pi fourths radians. Part B, express 5 pi thirds rad using degrees. We'll do the same thing. We'll take our value, multiply it by a conversion factor. So 180 degrees is pi radians. So multiplying those, the pi values cancel. That'd be 60 times 5, that'd be 300. So 300 degrees. Now, consider the following angle theta in standard position. The point P of xy, okay, is given here. So this is a point on our unit circle. We have our angle theta, and then we have this triangle set up. Now, the way that our trigonometric functions are defined is in terms of that triangle. So let P of x, or P of xy, be the point on the unit circle centered at the origin. Let theta be the angle with initial side of the positive x-axis. So our initial side is on the positive x-axis, and our terminal side is given by the line connecting it, or that radius there. The trigonometric functions are then defined as sine theta equals y, the y value of that point. Cosine theta is x. Tangent theta is y divided by x, the ratio there. Cosecant theta is 1 over y. Secant theta is 1 over x, and cotangent theta is x over y. So if you notice, these are reciprocals of each other. If x is 0, then secant and tangent are undefined. If y is 0, then tangent or cotangent and cosecant are undefined. This all holds if you have a radius bigger than 1. If you have anything that's greater than 0, this still works, except instead of saying x and y, it's y over r and x over r. All right, now here are some values for the major angles in the first quadrant. The beauty of this is all you need to know is the first quadrant. All that changes in different quadrants is that the x values or the y values might be negative. So just be careful about that. Always sketch an angle when you're trying to find something on paper so that you can see how it compares to one of the other angles, and then you're set up. So, example 2, evaluate each of the following. We have sine of 2 pi thirds. Well, pi is all the way, it's 180 degrees, so 2 pi over 3 is going to be an angle right over here. So really, our angle theta is that right there. But we are concerned about the x and the y values of a point over here. Okay. So really that's the point we're talking about. So if you notice, that angle in blue is equivalent to, or it's similar to pi over 3, except the x is negative. So, looking at that chart we have, that means, in this case, the cosine is the x. Okay, so sine is the y, it's going to be the same y value. So, it's similar to pi over 3, so pi over 3 has a value of root 3 over 2. And that is our sine value, because sine theta equals y. That's the y value at that point. Next we have cosine of negative 5 pi over 6. Negative 5 pi over 6 would be this direction. So we would have 6 over 6 is 1. So it's going to be a sixth off this direction, going that way. So our angle, we'll say this, and that is going to be similar to pi over 6. Similar to pi over 6, except the x and the y are less than 0. Okay. We have a negative x and a negative y in the third quadrant. So this is going to be equal to negative, since that is my x value, cosine of pi over 6. Now, cosine of pi over 6 is root 3 over 2, so this is negative root 3 over 2. Alright, next we have tangent of 15 pi over 4. Right, where is 15 pi over 4? Well, that is going to be 1/4 less than 2 pi, so that is going to go this direction right here. So our angle is right there. So 15 pi over 4 is similar to pi over 4. The x is positive, so there's nothing wrong with that, but the y is negative. So I'm going to write this as in terms of sine and cosine. Okay. But because our y is less than 0, negative sine of pi over 4. Now sine of pi over 4 is root 2 over 2, so that's negative root 2 over 2, and root 2 over 2 for our cosine, only place where the two are the same. And so we have that tangent of 15 pi over 4 is negative 1. Now, because we are talking about triangles, we can visualize the relationships here with the angle theta and this triangle formed using the radius, the initial side, and the terminal side. A useful acronym, there are actually several, but a useful acronym is SOHCAHTOA, which is sine equals opposite over hypotenuse. In this case, hypotenuse, let's just compare this to our previous. We had x and y, and we said sine was y over r, which is the opposite over the hypotenuse. Cosine, we said, was x over r in general, which would be the adjacent over hypotenuse. Adjacent over hypotenuse. And then tangent. Tangent theta was y over x, which in this case is opposite. Opposite over adjacent, which is where TOA is coming in. Now let's use this to determine the length of a ramp. A wooden ramp is to be built with one end on the ground and the other end at the top of a short staircase. Okay, stop there. Let's imagine what this ramp is going to look like. One end is on the ground, but one end is on a short staircase. the top of that. If the top is 4 feet from the ground, 4 feet from the ground, and the angle is 10 degrees, how long does the ramp need to be? That would be this distance here, which I'm going to label as R. Actually, no, I will label it H, in keeping with that acronym. Now, before I actually continue with anything else, I want to write out that this is equal to pi over 180 degrees. That is pi over 18. I want to use that value. My calculator, I'm going to keep it in radian mode, and I don't really like to work with degrees very often. A couple times we have to later in the course. Okay, so we can set up an equation which is sine theta equals, alright, so this would be sine theta equals opposite over hypotenuse. That would be 4 over h. Solving for h, 4 over sine, and we're going to go ahead and substitute for theta. It is pi over 18. 4 over sine of pi 18ths, pi over 18, is 23.04, and that is an approximately 23.04 feet. Next, we have several identities, trig identities. There are the reciprocal identities, which are actually based on the definitions of sine, cosine, tangent. Then we have the Pythagorean identities. Sine squared theta plus cosine squared theta equals 1. All the rest can actually be derived from there. The addition and subtraction